Okay, next up is trig functions of any angle. So as of right now, all we've done is SOHCAHTOA, right? SOHCAHTOA. That is for right angles. So you've got this theta here, and you've got an opposite side, an adjacent side, and a hypotenuse. But we want to be able to do that for any theta, right? Any theta between 0 and 360, and then beyond that, we want to be able to do it. So what you need is a point on the terminal side. So see this point right here, pretend we're looking at an angle. Looks like this, right? That's our theta. And I want to know the SOHCAHTOA, the trig functions for that angle theta. Well, we've got to pull a little bit of kind of a trick, not a trick, but using this, the fact that that's the coordinates of those points right there, we can actually make a right triangle. And then I have an opposite side, an adjacent side, and a hypotenuse. So looking at the fact that this is x is 3 and y is 4, that means I've gone from the center out 1, 2, 3 units. That means my adjacent is 3. And then the length of this one is 1, 2, 3, 4. So my opposite is 4. And then how do I find the hypotenuse? Well, we've got a squared plus b squared equals c squared. Except we're going to call this an x and a y. And this hypotenuse is actually the radius, so we call that r. So think of it as this, x squared plus y squared equals r squared. Now the only reason we change those letters is to remind us that we're now on a coordinate system so that we can pull this trick with any angle on a circle. All right, so 3 squared plus 4 squared equals r squared. And so on. R squared equals 25, which means r equals 5. So I've got all three sides. I could easily find the 6 trig functions for that. Just knowing the OA and P, I can apply SOHCAHTOA. So that's what this next section is all about. Here's what it looks like. Sine of theta is still opposite over hypotenuse. We're still doing the same stuff. It's still opposite over hypotenuse. We're just calling it x and y because now we have that point that's on the terminal side of the angle. And for any of those points, we can draw this little perpendicular line. It forms a right triangle, and we've got our opposite, our adjacent, and our hypotenuse. Oops, that's an H. So even though I'm calling them x, y, and r, doesn't matter, it's the exact same stuff. You just have to remember what the picture looks like. That x is the adjacent, y is the opposite, and then you just have to calculate the hypotenuse using this formula right here. And then everything else follows. Tangent is still opposite over adjacent. The main thing about this section that you've got to understand is this x and y that they're giving you is a point on the terminal side, and from there we can think of that as a right triangle, and that this distance from here to here, that's an x distance, right? Left to right is x, and from here to here is a y distance because it's going up and down. All right, let's try one of these. Evaluate the 6 trig functions of theta. All right, we've got our triangle here, right? Now my distance for x from here to here is 3. My distance for y is -3. Now that's the difference with these, is that now we can have positive and negative values, but it still works exactly the same. Okay, here's my theta. So that's my opposite. This is my adjacent. And I can easily find my hypotenuse, my r. So hypotenuse is r by doing 3 squared plus -3 squared equals r squared. Notice I put parentheses around it because -3 squared is 9, not -9. So we've got 9 plus 9. That's 18. R squared. So R is the square root of 18. But we're going to break down 18 into 2, 3, and 3. Got a pair of homies there that's going to break out. And I've got R is 3 square root of 2. That is your hypotenuse. We decided that our opposite was -3, and our adjacent is 3. So, 6 trig functions. Nice and easy. Sine is going to be -3 over 3 square root of 2. Looks like those 3's are going to cancel. I'm left with -1 over square root of 2. But, got to rationalize. So the sine is actually going to be negative square root of 2 over 2. Okay, there's sine. Now let's talk about, let's go to cosecant. Here's sine. Let's circle it to get it done and out of the way. Cosecant, remember, is just the reciprocal of that guy. Now, I'm not going to flip it at the very beginning. I'm going to flip it here before I rationalized it, because it's so much easier just to flip that upside down and say, oh, that's negative square root of 2 over 1, or negative square root of 2. Okay, cosine. This time it's 3 over 3 square root of 2, which is 1 over square root of 2, or square root of 2 over 2. So cosine is square root of 2 over 2, positive, and that means that secant is just positive square root of 2. Okay, let's go over here for tangent. Tangent's going to be -3 opposite over +3, so the tangent of theta equals -1. And then the cotangent of theta is the reciprocal of that, which is silly because it's the exact same thing. So there's the 6 trig functions for that angle that has this point on its terminal side. This was the x, that was the y,